Hello everyone, I am Wallace Marasigan, aka the Blue Ranger, and together with my fellow Flower Rangers, we are asking for your help to make the world a better place for all of us.
They've got a power and force that you've never seen before.
Now, our Earth is slowly dying, and we Rangers alone are not powerful enough to stop it. Our world is starved to death because of big corporations and their mass usage of Earth's resources, paired with their continuous discharge of hazardous materials into our planet's environment. One way we figured out how we together as one can save our dear planet is through the use of flora. But what in the hoo-ha is flora? Well, flora is basically all plant life. Basically what I'm saying is plant is what will save us all. In fact, plants has been one of the many key factors keeping us alive. Plants make up 80% of our planet. They give us the oxygen we need to continue living. We even eat some of them because of the nutritional values they have to offer. Not only that, but they are also very tasty. Now, you might think, if plants make up a high percentage of our planet, and it is what saves us, what am I blabbering about? Well, yes, plants will really do save us, but what you did not know is we humans are the ones also responsible why plants are slowly dying. We always build houses and other infrastructures everywhere. We kill plants all of the time, but only a little of us takes the extra effort of planting them again. I want you to observe your surroundings. Notice how only a little amount of plants are visible. The case are worse for other places. Because of our non-stop killing of plants, the effects on some areas are almost irreversible. So now you understand why we need your help. Further details on our mission would be discussed to you by my fellow Flower Rangers. So what are you waiting for? It's planting time!
The nitrogen cycle is a series of gaseous movement across the atmosphere, organism, and soil. Nitrogen gas is present in both organic and inorganic forms. It undergoes many transformations to maintain equilibrium in the ecosystem. In the first process, fixation, atmospheric nitrogen is deposited into the soil mainly through precipitation to convert into purposeful ammonia. It involves symbiotic bacteria which have nitrogenesis enzymes to transform nitrogen into ammonia. Afterwards, the ammonia undergoes nitrification to convert into nitrite and then into nitrate. Throughout assimilation, plants draw in the nitrogen compounds from the soil to form protein. This is also how the nitrogen compounds are passed down the food chain. At death, both plants and animals start to decompose and release the trapped nitrogen from the body back to the soil. Bacteria further break down the organic matter into ammonium and then into ammonia to supply other biological processes. Lastly, in denitrification, nitrate is reverted back into nitrogen due to bacteria combining it with oxygen. The nitrogen eventually returns to the atmosphere. The nitrogen cycle is integral to flora since it allows to synthesize chlorophyll from the nitrogen compounds, enrich the soil with necessary nutrients for cultivation, and decompose organic matter to provide for other processes. The sulfur cycle is an integral element to many different proteins, minerals, and cells. The sulfur cycle begins once sulfur compounds are released to the atmosphere from decomposition of organisms, volcanic eruption, and pollution. The sulfur from volcanic eruptions is combined with hydrogen, which is hydrogen sulfide. Clouds will then gather the hydrogen sulfide and rain it down into the soil. Microorganisms in the soil convert the hydrogen sulfide into sulfate. Plants absorb the sulfate through their roots and use it for photosynthesis. Sulfur compounds are passed down the food chain this way. Furthermore, the sulfur compounds from the rain also benefit marine systems. aquatic plants need sulfate to continue their growth. Eventually, the sulfur will return into the atmosphere and repeat the cycle again. The sulfur cycle balances the sulfur concentration throughout the ecosystem to provide the necessary energy and maintain a hospitable place for all living organisms. Plants need it for chlorophyll formation and continued growth. Sulfur absorbed by plants are further transferred the food chain to provide to different biological processes such as formation of amino acids and activation of enzymes.
Now that we know what the nitrogen and sulfur cycle are, let's look at the effects of activities on the nitrogen and sulfur cycles. In the case of the nitrogen cycle, human activity can release nitrogen into the environment by two primary means: the combustion of fossil fuels, which release different nitrogen oxides, and the use of artificial in agriculture, which are then washed into lakes, streams, and rivers by surface runoff. Atmospheric nitrogen is associated with several effects on the Earth's ecosystem, including the production of acid rain in the form of nitric acid or HNO3 and greenhouse gas in the form of nitrous oxide or N2O, potentially causing climate change. A significant effect of the fertilizer runoff is saltwater and freshwater eutrophication, a process where nutrient runoff causes the excess growth of microorganisms, depleting dissolved oxygen levels and killing ecosystem flora. For the sulfur cycle, human activities have played a significant role in altering the balance of the global sulfur cycle. Burning large quantities of fossil fuels, especially coal, releases large amounts of hydrogen sulfide gas into the atmosphere, creating acid rain. Acid rain is a corrosive rain that causes damage to aquatic ecosystems and the natural environment by lowering the pH level of the lakes, which kills much resident floras. It also affects the human-made environment through the chemical degradation of buildings. So now, let's learn about invasive species. Invasive species are any organisms that are non-native to a particular area. Invasive species can cause significant economic and environmental harm to the new area. Okay, so based on the definition of invasive species and the effect of human activities to the nitrogen and sulfur cycle, the question is, are we invasive species? Well, the answer to the question is no. While yes, human can cause harm to the environment, humans are non-native to the environment. Humanity is considered a part of the ecosystem because humans are everywhere, thus contradicting the non-native part of the definition of invasive species. However, some arguments still lead to the conclusion that humans are invasive species. For example, when humans discover and develop a place without humans, humans can be considered invasive species, particularly if they disrupt the native organisms. Well, instead of calling humans invasive species, it is better to define humans as the cause of invasive species. Why? Human activities are the main cause of organisms invading other locations and disrupting them.
Now let's go on with epigenetics. By altering gene expression patterns, plants may interact with their surroundings. Epigenetic changes, which impact various aspects of plant growth and development, are one mechanism for in this interaction. Therefore, the epigenome is the hugely dynamic in response to environmental signal and changes in a developmental state. The environment influences a group of genes that regulate flowering throughout changes in how they express themselves. This promotes transgenerational seed production by ensuring bloom output even when plants develop in challenging environments. Recent research on the epigenetics alteration connected to flowering in Arabidopsis thaliana cultivate under abiotic stress conditions like cold, drought, and high sun is presented in this review. These epigenetic modifications include DNA methylation, histone modification, and the production of the microRNAs, which mediate these changes. Also covered are the function of the photohormones, auxins, and abscisic acid. In chromatin remodeling, it is demonstrated that there is a significant connection between the epigenetic changes related to the floral initiation and development, and the changes that related to stress tolerance. This connection is supported by the fact that plants control stress tolerance and flowering through similar epigenetic patterns. This may be used to identify new epigenetic agents. Thank you.
Le Chatelier's principle states that if an equilibrium is subjected to change, it will create a new equilibrium where it provides a counteraction against the new changes. This concept is usually applied in chemistry and thermodynamics, but it can also apply to our everyday surroundings. Going back to the nitrogen cycle, due to an excessive use in fertilizers, nitrogen that was not absorbed by plants and crops runs off to nearby bodies of water, causing eutrophication. If we apply Le Chatelier's principle, there should be a counteraction or consequence due to the rising levels of nitrogen in the water. And that consequence comes in the form of algal blooms springing up to consume nitrogen, which can contribute to a harmful environment for fishes due to low oxygen levels.
Our ecosystem is suffering at the hands of those who benefit from it, humans. Other organisms can indeed survive without the presence of humans, especially plants. However, we humans cannot survive without them. We should stop performing human activities such as burning fossil fuels and excessive use of fertilizers. Instead of burning fossil fuels, we can utilize hydropower, biomass, wind, geothermal, and solar power as a source of energy. Instead of commercial and artificial fertilizers, we should use organic fertilizers, which by doing so brings balance to the nitrogen and sulfur cycle. If we did not take action starting right now, then when? The ecosystem is dead? Of course not. Alright then, it's saving the ecosystem time.